Hello everyone, let us discuss about the topic control systems under unit 2 of time response analysis, measures of the performance of the standard first order and second order system. Objective, the main objective of this video lecture is to learn the various measuring performance of the standard first order and second order system. First, this diagram is represented for first order system. So here I am giving the input as R of S, and this is a summer, and then the summer output is a error signal. Because the feedback signal is negative, means subtract R of S minus C of S is nothing but E of S. So first the closed loop transfer function. So C of S by R of S is equal to G by 1 plus G, or G of S by 1 plus G of S. You know already this one. So here the G of S is nothing but 1 by tau S here. So 1 by tau S divided by 1 plus 1 by tau S. You can rearrange and taking the common factor for this, the denominator function. So finally we obtained 1 by tau S plus 1 is the first order standard first order system. So now instead of R of S, we can put unit step input. That is a response to unit step input for the first order standard first order system is C of S is equal to R of S into 1 by tau S plus 1, where R of S is unit step means 1 by S. You can substitute R of S by 1 by S. So this is where response for unit step input in the time domain analysis. You can take the partial fraction for this. 1 by S into tau S plus 1 equal to A by S plus B by tau S plus 1. So take a common factor. A into tau S plus 1 plus BS is equal to numerator term 1. So put S is equal to 0 for this equation. So find A value, and similarly put S is equal to minus 1. Find the tau value, B value. B value is nothing but minus tau. Okay, you can substitute A and B value in the partial fraction, so that you can obtain the C of S is equal to 1 by S plus minus tau by tau S plus 1. Taking inverse Laplace for the C of S, we can obtain the C of t. So what is the inverse Laplace of this? 1 by S is nothing but 1. So 1 by S plus A is nothing but e power minus at. So C of t is equal to 1 minus e power minus t by tau. So for the error signal, is nothing but R of t minus C of t. You know R of t is 1. So 1 minus C of t is equal to 1 get cancelled. So that e power minus t by tau. This is the error signal for the standard first order unit step input. So this is this response is nothing but the unit step response of the first order system. So this one is a C of t, this one is the error signal. So here the tau is there. So what is the initial slope of the curve at t is equal to 0? That is dc by dt is equal at t is equal to 0. You can substitute t is equal to 0 for this equation. 1 by tau e power minus t by tau. So that means 1 by tau only, where tau is the time constant of the system. The time constant is indicative of how fast the system tends to reach the final value. The speed of the response can be qualitatively defined as the time for the output to becomes a particular percentage of its final value. Okay, so this is a various effect of time constant on a system response. So here this one is a tau value. Tau is equal to tau 1, whereas this is the response for tau is equal to tau 1. So this one is a tau is equal to tau 2 is less than tau 1. Okay. So for that is here TS2 and TS1 is the relationship between TS2 and TS1 is TS2 is less than TS1. So according to that, a large time response to sluggish system, a small time constant corresponds to fast system. So that E of t is equal to R of t minus E of t, which is equal to e power minus t by tau. The steady state error. So ES is equal to limit t tends to infinity. E of t is equal to e power minus infinity by tau, that is equal to 0. So for the system tracks the unit step input with the 0 steady state error. So next one is a impulse input for the standard first order system. So here I am substituting the R of s by 1. So 1 by tau s plus 1, C of s is equal to. So you can taking the inverse Laplace for this. So 1 by tau into e power minus t by tau. This is a impulse response of the first order system. This the response represents. So next one is the unit ramp input. So unit ramp input means you can substitute R of s by 1 by s square. So taking partial fraction for this. So 1 by s square into tau s plus 1, a by s square plus b by s plus c by tau s plus 1. Taking common factor for this. So 1 is equal to a into tau s plus 1 plus bs into tau s plus 1 plus c s square. Put s is equal to 0 for this. Find the a value and put s is equal to minus 1 by tau and c value is tau square and put s is equal to 1. So b value is minus tau. So you can find a, b, c value. Substitute this a, b, c value in a partial fraction form. So C of s is equal to 1 by a square into tau s plus 1 is equal to 1 by a square minus tau by s plus tau square by tau s plus 1. You take the inverse Laplace for this equation. You can obtain the C of t. So C of t is equal to t minus tau plus tau into e power minus t by tau, because 1 by s square is equal to t. Okay, 1 by s is equal to 1. So 1 by s plus tau is equal to e power minus t by tau. So we take tau as constant, that is tau as a common factor for these two terms. So 1 minus e power minus t by tau. So what is the e of t? You know already. So r of t minus c of t, just substitute. So t minus c of t. C of t is this one. So you can substitute instead of c of t. So t get cancelled. So that e of t is equal to tau into 1 minus e power minus t by tau. The steady state error is ES is equal to limit t tends to infinity. E of t is equal to tau into 1 minus e power minus infinity by tau. So is equal to tau. So E as a steady state error is equal to tau. So this is a relationship between time versus C of t and R of t. This is a steady state error. This is a R of t. This is a C of t. This one is R of t. The first order system will track the unit ramp signal with the steady state error tau. So next to the time response of the second order system, the standard second order system is look like this. So here this is a block diagram for the standard second order system. Here the R of s is the input signal, this one is the error signal, E of s, and then the standard second order system is omega n square divided by s into s plus 2 zeta omega n with feedback unity feedback. Okay, you can substitute. What is the find out the C of s by R of s is G of s by 1 plus G of s, you know already, because the unity feedback H of s is equal to 1. So that omega n square divided by s square plus 2 zeta omega ns plus omega n square. So this is our standard second order transfer function, where zeta is a damping factor or damping ratio. Omega n is nothing but undamped natural frequency. So the denominator of the closed loop transfer function is equal to 0 is nothing but characteristics polynomial, which is equal to 0. S square plus 2 zeta omega ns plus omega n square is equal to 0. You can find the roots of this characteristics polynomial. So that minus b plus or minus root of b square minus 4ac divided by 2a. You can substitute this formula into your equation where a is equal to 1, b is equal to 2 theta omega n, c is equal to omega n square. So that having two roots, because the second order system is having two roots. So S1 and S2s are minus 2 zeta omega n plus or minus root of 4 zeta omega square omega zeta square omega n square minus 4 omega n square divided by 2, which is equal to minus 2 zeta omega n plus or minus root of, you take it omega n square is outside, 4 omega n square for these two terms. So 4 omega n square into zeta square minus 1 divided by 2. Okay, so taking the roots for this one, 2 omega n. So that minus 2 zeta omega n plus or minus 2 zeta omega n root of zeta square minus 1 by 2. So you can take the 2 as a common for these two terms, that is take it outside and cancel out. So after that minus zeta omega n plus or minus omega n root of zeta square minus 1. So here you take outside omega, that is minus 1 for this square root. So zeta omega n plus or minus omega n root of minus 1. So that 1 minus zeta square. Okay. So instead of minus 1 you put j square. So that you can j square is root of j square is only j. So your S1 final roots of the S1 and S2s are minus zeta omega n plus or minus j omega n into root of 1 minus zeta square. So you can assume this as a omega t, that is a damping natural frequency, is nothing but omega n into root of 1 minus zeta square. So that your final roots of this S1 and S2s are minus zeta omega n plus or minus j omega d. So the time response of the second order system for unit step input. So before that, so depending upon the zeta value, the second order system can be classified into undamped system. That means the zeta is equal to 0. So underdamped system means the zeta value is in between 0 to 1, and critically damped system is equal to 1, and overdamped system is greater than 1. So these are all the classifications for depending upon the zeta value. So first, if the response of the undamped system for unit step input, the second order system, standard second order system transfer function you know already. So C of s by R of s is equal to omega n square divided by s square plus 2 zeta omega ns plus omega n square. Now we can find out the response of the undamped system. That means undamped means zeta is equal to 0. You substitute zeta is equal to 0 means the equation becomes C of s by R of s is equal to omega n square divided by s square plus omega n square. So that C of s is equal to R of s into omega n square divided by s square plus omega n square. You can substitute instead of R of s 1 by s, taking partial fraction. So that a by s plus bs plus c divided by s square plus omega n square. So equate this, the numerator terms. So omega n square is equal to a into s square plus omega n square plus bs plus c into s. So now you can substitute this s is equal to 0. You can find a value as 1. So equating the coefficients of s square, that is a plus b is equal to 0. B is equal to minus 1. Equating the coefficient of s, c is equal to 0. So after you find the a, b, c value, you can substitute in the partial fraction, that is the c of s. And then taking the Laplace transform for the inverse Laplace transform for this equation, you can find c of t. Okay. So C of s is nothing but 1 by s minus s by s square plus omega n square. Taking inverse Laplace. So this one is a cos omega n. So you already know 1 by s is inverse Laplace for this one 1. So s by s square plus omega n square is nothing but cos omega nt. So this is where system is oscillating system. So the response of the undamped system for unit So the response of undamped system for unit step input is completely oscillatory. So next one is the response of critically damped system for unit step input. Critically damped means you can substitute the zeta is equal to 1. So C of S by R of S is equal to omega n square divided by S square plus 2 zeta omega ns plus omega n square. The standard second order transfer function. You can substitute zeta is equal to 1 for this one. So that will be omega n square divided by S square plus 2 omega ns plus omega n square. So this is nothing but S plus omega n whole square. So taking the partial fraction for this one. So A by S plus B by S plus omega n plus C by S plus omega n whole square. So omega n square is equal to A into S plus omega n square plus BS into S plus omega n plus CS. Put S is equal to 0 for this equation. So find A value. A is equal to 1. And then equating the coefficient S square so that A plus B is equal to 0. B is nothing but minus A, where A is 1, so that B is equal to minus 1. And then equating the coefficient S, so that 2A omega n square plus B omega n plus C is equal to 0. A value is 1 already find out. And then B value is minus 1. You can substitute this here. So 2 into omega n minus omega n plus C is equal to 0. You can subtract these two. So omega n plus C is equal to 0. C is equal to omega n. After you can find out A, B, C value, substitute in C of S. So that omega n square divided by S plus omega n whole square is equal to 1 by S minus 1 by S plus omega n plus omega n divided by S plus omega n whole square. So taking the inverse Laplace for this C of S, we can obtain C of t. So that is nothing but 1 minus e power minus omega nt minus omega n into t into e power minus omega nt. So that the output of this response is this one. So here the response have no oscillation. So next one is the response of underdamped system for unit step input. Okay, second order system for unit step input. So that underdamped means the zeta value is in between 0 to 1. So that your C of S is equal to R of S into omega n square divided by S square plus 2 zeta omega ns plus omega n square. Keep it as this as such. Okay, omega n square divided by S into S square plus 2 zeta omega ns plus omega n square. You are taking the partial fraction for this one. A by S plus BS plus C divided by S square plus 2 zeta omega ns plus omega n square. So omega n square is equal to A into S square plus 2 zeta omega ns plus omega n square plus BS plus C into S. Put S is equal to 0 for this equation. You can find A is equal to 1. So similarly, you can find B and C value. After you can find the B and C value, you can substitute in the C of S 1 by S minus S plus 2 zeta omega n divided by S square plus 2 zeta omega ns plus omega n square. So you can take the inverse Laplace for this equation. You can obtain C of t. So before that, not a simplification. So adding and subtracting zeta square omega n square in the denominator of the second term, this term. Okay, so just you can add and subtract. So S plus 2 zeta omega n divided by S square plus 2 zeta omega ns omega n square plus zeta square omega n square minus zeta square omega n square, because I am writing this numerator term into standard inverse Laplace form. Okay, so that 1 by S minus S plus 2 zeta omega n divided by S square plus 2 zeta omega ns plus zeta square omega n square. You can combine these three terms. This is nothing but A plus B whole square form. Okay, so here in this term, these two terms, omega n square is, take it as a common. So omega n square into 1 minus zeta square. So that you know already what is omega d. Omega d is omega n into 1 minus zeta square. You can substitute instead of that omega d square. So that 1 by s minus s plus zeta omega n divided by s plus zeta omega n whole square plus omega d square. You can split the numerator and denominator term into separate. Okay. So zeta omega n divided by s plus zeta omega n square plus omega d square. So that here you can multiply the third term and multiply and divide by omega d in the third term. Okay. So because the standard form is nothing but this one, s plus zeta omega n divided by s plus zeta omega n square plus omega d square. So this is nothing but cos of omega dt, and then this is the sine of omega dt. So that zeta omega n, take it outside by omega d. Omega d by s plus zeta omega n square plus omega d is, there is a standard form for this one is cos that is e power minus at into cos omega t. That is s plus a divided by s plus a whole square plus omega square. This is a cos, equivalent is cos 1 minus e power minus zeta omega nt cos omega dt. Similarly, this one e power minus zeta omega nt into sin omega dt. Okay. So u of t is equal to 1 minus, not c of t is equal to u of t into 1 minus e power minus zeta omega nt cos omega d into t minus zeta omega n divided by, you can, what is omega d? You know already. So omega n into root of 1 minus zeta square e power minus zeta omega nt sin omega dt. So omega n get cancelled. So that the remaining term for u of t is equal to 1 minus e power zeta omega nt divided by root of 1 minus zeta square, because I am multiplying and divide by 1 minus zeta square root of, so that you can form the triangle. So this one is the root of 1 minus zeta square, here zeta, here 1, this is a theta. What is cos theta? Cos theta is nothing but zeta. Sin theta is root of 1 minus zeta square. Tan theta is equal to root of 1 minus zeta square by zeta. So you can write this term e power minus this term, that is a 1 minus zeta square is sin theta, and then zeta is cos theta. Okay, so you can write sin theta into cos omega dt plus cos theta into sin omega dt. Okay, so this is a sin a plus b form, sin a cos b plus cos a sin b. So after you can write this, c of t is equal to u of t into 1 minus 1 by root of 1 minus zeta square e power minus zeta omega nt into sin omega dt plus theta. Okay, so theta is cos inverse of zeta. So this is a various values of zeta value. So the zeta value is 1. This is a 0, that is the oscillating response. So that this is a 1.8 like this. Okay, so omega natural frequency is equal to common. Okay. So that u of t, c of t is equal to u of t into 1 minus 1 by root of 1 minus zeta square e power minus zeta omega nt sin omega into root of 1 minus zeta square t plus theta. The theta is cos inverse of zeta. So this is a standard second order response, where this is a raise time, this is a peak time. TR is the raise time, TP is a peak time, where TS is a settling time. So having some there is a percentage of oscillations is there in the settling time. So references, these are all the references I referred for preparing this video lecture. Thank you for watching this video.